simplifying with exponents. This is actually pretty easy when we kind of get an explanation of what it's actually going on here. So let me show you. Let's look at this example right here. Okay, you'll notice that you have 5 and it's to the power of 1, and you're multiplying that times 5 to the power of 4, and you're multiplying that times 5 to the power of 6, and you're multiplying that times 5 to the power of 2. Now, all of these bases or roots are the same, right? All these bases are the same. So what really is going on here, this one says I have 1 5, and I'm multiplying it times what? 4 5s. This one says I'm multiplying it times 6 5s. See that? This is 2 5s. So really, how many 5s are being multiplied? Well, you could just count all these 5s, which is really the same thing as taking these exponents, which tells you how many 5s are there. Just add them up. 1 and 4, that's 5. 5 and 6 more, that's 11. 11 and 2, well, that's 13 5s are being multiplied together. So if your bases are the same and you're multiplying, again, you have to be multiplying, then you can just add all of these exponents together to get this sum. So let's give it a shot. Notice that on this example here, only these two bases are the same. They are not the same as these bases. So these bases on the left, you cannot combine them with these bases on the right. But can I combine these two? Yes. Can I combine these two? Yes. So let's do that. Let's go ahead and show this. Now we're only simplifying. Again, we're not showing real answers, we're just simplifying. So 4 to the power of 1 times 4 to the power of 3 is actually 4 to the power of 4. And I'm multiplying that times 2 to the power of 4 times 2 to the power of 6, which is 2 to the power of 10. So I'm taking that and I'm multiplying it to 2 to the power of 10. Now, when you do division, it's actually the opposite. You're not going to be adding these bases. You're actually subtracting these bases. So these exponents. So if your bases are the same, like for instance, the base 4 to the power of 7 and the base 4 to the power of 3, you're dividing 4 to the power of 7 divided by 4 to the power of 3. Well, you don't add these exponents because you're not creating more 4s. You're reducing the number of 4s that are up there. So you would actually take 7 and subtract 3, leaving 4. These are the number of 4s that still remain. 4 to the power of 4. Let's try it again. Look down here. You'll notice that you have 12 4s on top, and you're dividing it by 4 4s. Are the bases the same? Yes. So guess what? If these bases are the same and we're dividing, we subtract them. Now, it's always from first minus second. Okay? For instance, what I mean by that is it's the first number, 12, divided by, or subtracting the 4 out. So it would leave 8. So how many 4s are still there? 8 are. Let's try it again. 4 to the power of 8 divided by 4 to the power of 2. Well, 8 take 2, leaves 6. So this is 4 to the power of 6.